Today's program is a greeter scrambler. So greeter scrambler, let's break that down. One is it is a greeting program. So it's going to have some kind of greeting for the user, and it's going to have different greetings that we can choose from. The other part is that it's going to scramble all of its output. Scramble all output. So whenever it prints it, it's going to mix it up, kind of like the word shifter lab did, which was lab 6. So to get this started, we're of course going to have a variable for hello that has our greeting in it, and then we'll print that variable. And if I were to just go ahead and run that, I'll resize this so it's over here. It would just go ahead and print out hello, no surprises there, right? At this point, this makes perfect sense to you. Let's go and add on a little bit there. We're going to add on to it as if it were, as if we were in an actual social situation and we'd want to have multiple options of greetings. So I'm going to make another variable. It's going to be called S-type, and I'm going to say the type of greeting is inquiry. So we're not going to just say hello, but we're going to ask how the other person is. So I'm going to do this through an if statement, so that way we have a choices, so we can change what we might need to. And I'll go inquiry, and there we go. Alright, now you know that we can do this, hopefully. That we can test that check if two strings are equal to each other, just like that. We did it in the May conditions lab. Now I'm going to add something else in there. I'm going to write s plus equals how are you? And you'll notice there's something a little different I haven't really done in any of the other example problems. This plus equals is the exact same thing as saying this, s equals s plus, how are you? You see, when you do any operator with an equal sign like this, where it's that operator and then equals, you are doing it onto that data. So with s plus equals how are you, it isn't s equals how are you, where I'm going to remove this plus sign and then run the code, and you'll notice that it just changes it to how are you. But when I do plus equals, it builds onto it. It concatenates it. Just the same way as if I had s equals s plus how are you, concatenating it there and saving it into the variable s. If I just do s plus equals, it'll add it on to the existing value. You can also do that for numbers. And for numbers, you can also do times equals, divide by equals, all that. So in its current form, we have s starting as hello. Its type is an inquiry. Finding that s type is indeed an inquiry, we add on how are you. And there you go. There you go, right there. Alright, so still hopefully pretty straightforward. You just have to learn the new plus equals thing. I'm going to add in a couple of more conditions. I'm actually just going to copy this from this version. So you can see it. I got inquiry, just greeting, leaving. Because interestingly enough, a greeting can also be a goodbye. You know, if I were to have this be leaving, you'll notice now. Perfect. Get out of a social situation free card right there, in case you wanted to screenshot that. So yeah, right there we can control what type of greeting we're going to give based on this S type up here. As long as it matches exactly the statements down here, we can grab it right there. There's something that's just a greeting when you don't care how the other person is doing. And for anything else, it'll just say hello. Alright, so hopefully you can see how that works. I'm going to change it back to inquiry. You can see that it works just fine, and we're all good. But let's go ahead and add on to it a little bit more now. You see, I'm going to change this to inquiry with a capital I, sentence case. Because you see, sometimes data comes in funny or differently than expected. And if you try to run it like this, it doesn't recognize inquiry, because this is technically not the same as that, because of that capital I. We would have to make this one capital in order for it to work. But then, if this one was lowercase, well, then it doesn't work again. You know, or if, or we could also change this back to a capital, S type to capital, and then down here for this first if statement, I go if S type equals inquiry, or S type equals inquiry, you know, then we'd be fine. But then what if I, you know, accidentally had a capital Y there? You know, we can keep going on, and you keep adding on more conditions, but that's just going to be a lot of extra work. And it's going to be kind of pointless when there's a much easier way of doing this. I'm going to keep all these comparisons as lowercase. And then up here, I'm going to do something I need you to learn, which is I'm going to lowercase S type itself, so that whatever it is, it will now be lowercase. And I do that through the dot lower function. You see, when I set S type equal to itself dot lower, that right there, this part returns the lowercase version of that. And then since I have it set equal, it will actually change the value. If I do not have this highlighted part, S type equals, S type will not be changed by dot lower. But if I do, then, and I run it, then we have no problems. It can recognize that they are the same, even though originally it had two capital letters. Now, because I'm saying it's a lower, it can match this. So by making sure that these are lowercase and setting whatever is inputted as lowercase, I'm guaranteed that capital letters won't throw my program off. But that will. I just added a space right there, and that will totally throw off my program. It won't understand that's supposed to be an inquiry. So here's our next thing we gotta learn. I'm gonna set S type equal to next, after I've already lowercased it, S type dot replace. And I'm gonna type it out first, and then I'm gonna describe it. Replace is a function which takes two arguments. The first argument is the character or characters to find and remove from the string. So I do S type dot replace. It looks for whatever's in these quotes, and then replaces it with whatever's in these quotes. Now notice I'm using single quotes here. You could do this with double quotes, and there'd be no problem. However, I like to use single quotes because I'm representing the fact that there's only a single character here, and that's typically, traditionally been how we do that. But you could make these double quotes. Now with this, it's going to look for this character, which is the space. And all of the examples of the spaces that it finds in here, it's going to replace with whatever's between these two quotes. However, notice there's nothing between those quotes. That means it's going to replace it with nothing. In effect, it'll just remove them. So whenever you want to remove a character or a series of characters from something, then you go ahead and use this replace function, because then it will clean it on up, and it will work just fine. So that works for that. Let's carry on. I'm going to do this one, and I'm going to make it all vaporwavy and fun, and look at that, I even got periods in there. Do you think it'll work? Of course not. It doesn't recognize that leaving is leaving. Even though it makes all these lowercase and gets rid of all those spaces, it doesn't see the periods yet. So let's go ahead and replace those periods too. Copy and paste that line, search for all periods, replace it with nothingness so that they are erased. And just like that, catches on immediately. And again, this is, no matter what I add to this, it's going to be just fine. It's going to remove them, and it's going to be able to notice what this word actually is. We wouldn't need it for this lab, but if you would like it, notice that I can also make this replace whole things. For instance, one thing, let's say we had a list of animals, and on that list were chickens, but we didn't want them to be chickens, we wanted them to be goats. That's how you'd replace it. So anyways, moving on. Make sure you have that lower, the replace, and at the end of it all, let's also add in the upper, which again doesn't change S. We can see that because if I were to print it out twice, you'll notice it'll do it capitalized and lowercase, or sentence case. S.upper is how we'll leave it. So that way it prints out the uppercase version of whatever this is. And it works just fine. Alright, so hopefully you got that. Lower, replace, upper, and the plus equals. If you got all that, then we got our first part down. Next we have to scramble all of our output. Moving on to part 2, we have to actually scramble our output. Because right now, well, it's too readable. So let's fix that. And I know, typically you want a greeting program to be readable, but we don't in this case. So let's get our scramble S right here. Alright, let's take a look at how we should do this. So, start off. The best way of doing this is by getting little breakpoints in the splicing. So remember, this is called splicing. And we're going to do some advanced splicing here because we're not going to divide it into halves, but rather we're going to divide it into thirds. So watch this. I'm going to go ahead and make two variables, one for first third, one for second third. So it's going to know where to break each point. For instance, for the first third of our word will go from 0 to this first third variable right here, which is going to be equal to the length of our string, integer division 3. Second third is going to be the end of the second third of the word, meaning that that part of the string will go from first third to second third, and that's really just first third times 2. You know, it's a bit of math right there. I'm sure you got that. You can see how 1/3 divided by 2 multiplied by 2 makes 2/3, hopefully. And lastly, let's actually just write that line out because we're basically ready. What I want to do is I want to turn something that's 1, 2, 3 parts into just being 2, 1, 3. All right. So, for instance, if I had the word, if I had how, just how on its own, very easy to translate into that form. It'd be O and then H and then W. All right, so that you're basically just swapping around the first two pieces. Now, in addition to that, I'm also going to add in some underscores to show exactly where the breaks themselves are, so that way we can get a very clear idea of where it is. I know with how it's pretty easy because it's only 3 letters, so each third is just 1 letter. But we'll have some trouble with it when it gets a little larger. But here's us scrambling it up. So I'm going to go S equals. In this case, I would do S equals, not plus equals, because I want to replace the old value with this new value. I don't want to keep the old value and just add on to it. So I'm going to do S equals, S from the first third to the second third, plus underscore, plus S from 0 to the first third, plus underscore, plus S from the second third. And now, a few of you know this already. You can do it without putting anything there, and that'll work just fine. And that'll go from the beginning of it, from this part to the end. You can also do a length of S right there. Either one works fine, but notice how I've added up the first third, the second third, an underscore. So I've added the second third of the word, an underscore, the first third of the word, an underscore, and then the last third. And if I run that, originally it was I was just leaving, so let's look at that. Hello, right there, there's the first third, was just to leaving. Alright, and that's it. that's really all we needed for our scrambler. You know, you're already pretty aware, I'm hoping, of the, of how to divide it up, but just notice how this time we're doing it in thirds instead of into halves, and then your lab will ask for quarters. I'm sure you got that. Sure you can understand the simple math here. And if you have any questions, you let me know, okay? Great. Have a good one.